Hello? Alright. Alright, listen up, you people. So now, this is the BC exam, and the year on this one is a practice exam, and I believe it's the 2016. Yeah, 2016. So, okay, so for this one right here, it says depth of water in tank A in inches is modeled by differentiable and increasing function. That's important, increasing function. Function h4 from 0 to 10, where t is measured in minutes. The value of ht is for the selected value of t are given by the table above. Use the data in the table to approximate h prime of 6 to show the computation leads. Your answer include units of measure. Okay, so first, now, h prime means we're doing what? The derivative where?
6.
At 6. Now, is there 6 on here? No, because I'm trying to find the slope, right? So, it's basically slope formula. So, I'm going to have h prime. So, h prime of 6 is equal to, so 6 is going to be between these two right here, right? So, let's find the slope in between those. It's going to be 18.5 minus 15.5 over 7 minus 5. Now, this is a calculator portion of the test, so you can use that. So, what do we get? 3/2? Yes?
Yes.
Okay, so it's going to be equal to 3/2. Now, what's my units?
Per minute.
What is it?
Per minute.
Per minute.
Inches.
Okay, so that's going to be what? Inches per minute, right? Because from this one right here, so this is the height, right? And so when I take the derivative of that, that's going to be the velocity, right? So it's changing over time, isn't it? So since this is going to be the change over time, this is going to be my, it's going to be my inches per minute. Good morning.
Happy Teacher Appreciation Day.
Oh, thank you. All right. Okay. So this one right here. So on your test, this one right here is just going to be 1 point. So answer with units. So if you have the answer correct and you don't put units, you don't get points. So it has to be with units. So that's 1 point there.
It
Okay.
does say to indicate given.
Huh?
It does also say indicate given.
Yeah. But like I said, 1 point on the other exam, the AB exam, it was 1 point for answer, 1 point for units. So, but this one, if it, either way, this is all just 1 point. Approximate the value from 0 to 10 h of t dt using Wright-Riemann sum with the 4 subintervals indicated by the data in a table. Is this approximation greater than or less than 0 to 10 h of t dt? Give your reason for your answer. So, let's set up my function. So it's going to be h of t. Okay, and it's integral from 0 to 10, and that's dt. Yes, that one right there. Now, let's take a look, and let's do my intervals. So it says 4 subintervals. So let's see. So I'm gonna, my 4 subintervals are going to be here, right? So 0 to 2, 2 to 5, 5 to 7, and 7 to 10. So I'm gonna write that out. 0 to 2, 2 to 5. What's the next one? 5 to 7?
Yes.
And 7%.
And 7 to 10. All right, so this is important actually, writing this out. I like showing a lot of work. I do, especially if I'm trying to grade this by an AP grading standards. Showing more work is more helpful. So you're listing out everything you have. So now this is going to be a right-hand Riemann, right? Riemann sum in what shapes?
Rectangle.
Rectangles, right? So I'm going to have a rectangle, so my delta x, okay, so as you write this out, it's going to be equal to my delta x. So what is the delta x for my first one?
2.
So it's 2 times. Now, the f of 2 right hand, it's going to be of the right hand number. So what is the value h of 2?
10.
10
Yes.
plus 3 times
15.5.
H of 5,
h of 5 is what?
15.5.
15.5. Thank you. All right, sorry. Plus delta x,
2.
2 times
H of 7, which is 18.5.
18.5 plus delta x,
3.
3 times
20.
2, 0?
Yes, 2, 0.
Okay, there we go. I'm just making sure that I'm hearing correctly. All right, so I have everything listed out there. So now from there, I'm going to do what? Calculate it out. What do we have?
163.5.
16 what?
3.5.
163.5. What are my units?
Inches squared. Or it's
Okay, let's go back. Let's go back and talk about what we're doing right here.
Just inches.
Okay.
So this is the total volume from the water.
Yes, this is going to be the total amount, right?
Total depth.
Total amount of water. So this is actually, as it's going into the tank, right? We're talking about a volume because it's the water going in. So it's not going to be an area. This is going to be the volume, the amount of water going in. Okay? So I go to my units and it's going to be, what were the units on my water? Inches of water, right?
Total depth.
165. Okay, so now that's not the only part, right? Okay, so last part, give your reason for, so is this greater than or less than? Is that overestimation or underestimation?
over.
It's an overestimation. Why?
Because it's increasing in right hand. When it's increasing, it goes over.
Very good.
Goes over.
So all right hand Riemann IEMA, all are over estimations for a increasing function. And where do we get that information?
So
Differentiable and increasing. Okay, differentiable and increasing there. If you want to also sketch a graph and using justification and seeing the graph and say C graph for whatever, you know, that this is going to be an overestimation. Okay. All right. Just my answer. Depth of water in tank B in inches is modeled by that function. For 0 to 10, where T is measured in minutes, find the average depth of water in tank B over the interval 0 to 10. Is this greater or less than the average of tank A over the interval 0 to 10? All right, so average. So for tank A, how would I do that one? Okay, so it's going to be 1 over B minus A, which is 10, right?
Yeah.
Integral 0 to 10, right? And for my previous function, I could write it as h of t. Okay, you don't actually have to write out the whole, like whatever it is. So you'd say h of t on this one because it's already stated to you before. Okay? It's been stated to you before, so that's going to be h of t dt is going to be approximately what? 16 point.
What is the last one?
I know the last one, right?
163.
Yeah, it's 163.
163.
16.3.
Isn't that a right
No, no,
payment?
no.
So it isn't
Sorry.
like really accurate though.
But that's the only,
We can do like a.
Yeah.
it's a point. It doesn't matter. 16.25, because 163.5, and then divided by 10.
Yeah, it's not.
I thought you were saying that.
1635. Yeah, right there. Okay. And now tank B G of T D T. All right. This is number 1, isn't it? Say yes. Okay, what do we know about number 1? Question 1 is always say calculator.
Oh,
Calculate.
Yeah, so what should we do with this one right here?
Just plain.
I don't want to do that math, especially on a question like this, where it's timed. Plug it in the calculator, 1/10, 0 to 10 of that function. And what do you have to make sure when you pick up that calculator? Radians, right?
true.
What's true?
Radians.
Was it not there?
No. But it is there. 166, it's not. But it doesn't matter because you can.
Anyone get it yet?
16.624.
16 point what?
624.
624? Okay. Did everyone else get that?
Yeah.
Okay. So, now, so it's asking, is the value greater than or less than the average depth of the water of tank A over the interval? So which one's greater?
Take B.
Tank B, right? So, average depth of tank B, tan B, man, come on now. Is greater. Than average of tank A. So if you want to actually just do your little alligator, 16.624 alligator, 16.35, right? Okay, and one more thing I should probably add. What should I add here? Brenda? Units. So, inches, 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 and inches, right? Are we okay here? All right. I don't think I. Okay, so let's look at the points. I didn't do the points on this one. So points on this one right here is, so if I have my integral, so my integral is all this is worth 1 point. This over here is worth 1 point. My reason is worth 1 point. Okay, did I do that on my previous one? Yeah, just 1 point there. So this whole question right here was worth 3. This one right here, for this one, it's going to be, let's see, it is integral. So we have our integrals. So this is going to be, it is, I think it's 1 point for all of this. Is 1 point because you already had this basically, so that's 1 point. And then this right here by itself is 1 point. And then my third point is answer with reason is 1 point. Yes? All right, last one here. According to the model given in part C, is the depth of water take B increasing or decreasing at time t equals 6? Give your reason.
Just take the derivative of g of t at 6.
Take the derivative of,
G of t.
okay, so let's say it's going to be g of t. What was the function? Can you read it for me, please?
3.2 plus 17.5 times the square root plus sine of 0.16 t. Or 0.16 t.
Like that?
Yeah.
Okay, so that's the whole function? Okay, so we're trying to figure out, is it going to be increasing or decreasing at that time? So that means that I need to try and figure out the derivative and see, and if it's positive, it's greater than 0, then it's going to be increasing at that time. If it's negative, it's less than 0, so it would be decreasing at that time. So let's go ahead and take the derivative of this. So I'm going to rewrite this first before I try to do any math for this, because I don't like having radicals. 3.2 plus 1, 17.5 parentheses sine of 0.16 t to the 1/2. All right, let's go ahead and do this. We got some chain rules going on here, don't we? So it's going to be g prime of t is going to be derivative of that, which is going to be, let's see, that goes away. It's going to be 7.5 times 1/2, right? 1/2,
That's going to be
and then I'm going to have sine of 0.16 t to the negative 1/2 times the derivative of the inside, right?
Yeah.
So derivative of that is going to be 0.16, right? So it's going to be 0.16, and then it's going to be times cosine of my 0.16 t. Now, did I have to do all that? Why?
Because you could graph the function and then go menu.
Graph the function, right?
Analyze menu 6.
Yeah.
5.
Okay, so as long as we actually say what we're doing, okay, it doesn't actually say show the work on this one. This one, I could just leave it right here anyway. So remember, AP tests, you don't have to simplify any of your work. Just do the whole thing. So this is nasty, but guess what? That's it.
You still have to say if it's increasing or not.
Yeah, I'm gonna have to do that by just showing. If I want to show the derivative, stop right there. Because if you go through and try to simplify it and you make a mistake on your addition or something like that or anything else, then it's automatically going to be wrong, even though that this step would be correct. Your derivative is right, but then just leave it alone. All right, so we get all that. And so now we could have just said, hey, let's go into my function. So I'm going to pull up my calculator on this one. So the calculator is right here. So right here, my scratch pad. I'm in radian right here. What was my function? So it's 3.2, right?
Yes.
3.2 plus 17.5, and it was times square root, right, of sine of 0.16x close. Is that everything?
Yes.
Okay, hit enter. If you notice, my graph is already in radian, right? So I'm trying to find what value? Trying to find at 6, right? So I know it's going to be right about here. So it's here anyway. So it's going to be way up there. Let me see if I could actually just pull this bad boy down. Right there. So I have it here anyway. There you go. So I have the graph, so I can see the graph. So let's go menu, analyze graph, and I want the dy dx. So I want the derivative at point. So right here it says position, and I'm going to put the number positive 6, right? Just hit the enter, number 6. Hit number 6 and a little box comes open. Hit enter. There we go. Now, it gives me this decimal right here. It gives me the decimal 0.877. If yours doesn't have 3 decimals, you can click on it, hit control, listen please, hit control menu, and it's going to right click for you. And it's going to open this up, and I want attributes. Crap, I clicked on the wrong thing. So I need, there you go, on the text, attributes. And so if you want 3, or if you want 4, if you want more decimals, you could change this one so your graph shows more decimals. Because that's usually an issue. When you're just looking at the graph, it doesn't show you enough. So I got my 3 decimals anyway. Okay, so I have my 3 decimals, so it's going to be, you know, according to the AP, all of my decimals are going to be correct. All right, so I have this. So 0.887. So I'm going to go that I'm going to have g prime of 6 is equal to 0.887. And so I could say that 0.887 is greater than 0. So it is what? Increasing. There you go. Okay, let's see numbers on this one. So basically this right here is your 1 point. And then this is another point right here. 1 point for this, 1 point for this. So I showed the derivative right here just because, you know, it's one of those things that you're going to have to do anyway, and some of the problems you need it, some problems you don't. All right. We okay with this one? How much time we got left? 15 minutes? Okay. So since everyone was not here, so let's see which one we're going to work on next. We're working on
Let's do one with the tail.
Okay, next one we're gonna work on is, I like 2, but the problem is 2 is vector. Vectors are super easy, but I did not get to cover any of those. So let's go with number 3. 3 is going to be the next one. So I'm going to give you guys like, let's say a couple minutes. Actually, let's do this. So I'm going to let you guys work on these together, and then I'm going to go over number 3 tomorrow in class.